Hey, got BA here, and we're doing part 1 of 6 on this one. This is an instructional video, and if you are in the program, subsequent parts will be presented over time. Very important point. This does not contain the full 6 episodes. Okay. Luther Jensen, who actually worked for Gann for over 20 years, goes into far greater detail than Gann does on how to use the squares, excluding the tunnel level. What is meant by that? Well, tunnel takes lengthy research, and in tunnel, Gann goes into far greater detail than Jensen and Bayer, any of them. Anything out there, Gann goes into greater detail. That book is the ultimate authority on this. So I don't mean to knock tunnel. I'm just telling you, if you want something to start off with to look at, okay, Jensen is the place to be, because you can see it's simple English, and you can see what he's trying to get at there. Okay, and I think that those are really important concepts for people to start out with. So what I'm doing here in this one is we're going to take a look at that, Mr. Jensen. Now, this is IBM. When you look at a chart, what you're actually seeing is price working through all these squares, and that's the key. If you go back through the Gann material, like in his master courses or other places, he's using squares. He constantly talks about squares. He talks about half a square, a third, fourth, whatever. Okay? He talks about subsequent squares, like taking a number, say 144 weeks, and just keep going with that. 144, 288, and stuff. If you look at the sides of Gann's squares that he had made up in his later years, you see that they're numbered on the sides and along as far as time, so he could move them as he went. All right. I could tell you a lot about the squares, but for this starter video, I'm just using some basics here. Price moves through squares, period. Price must be understood through that concept. Okay? Not these other crazy, well, price is doing this with geometry and stuff. You have to know what square to use, and you have to know the dynamics that are operating inside that square. Key critical concepts. This is an illustration. There's different types of squares and different sizes operating in the market simultaneously. The red one here is meant to represent the planetary square. That is an IBM. And then you see the other ones. You see the purple pink running across the bottom. Those are subsequent squares. As an example, that would be 144, 288, and so on. Subsequent squares starting from an origin. The green one would be a different type of square, like the type of square as an example that would be in the square of 9 or another square, right? So there's multiple squares, so you have to know the dynamics. The dynamics of the red square here is different, completely different than the green square. And what do I mean by that is the tools that you use within a square to make that square operational are completely different in the red versus the green versus the purple, pink purple, whatever color that is. We'll use pink purple. Okay, so the dynamics are different. Now, is there overlapping factors? Yes, there is, and we'll take a look at one of those. There are several overlapping factors. They are found in all squares. We're going to take a look at one. And so some of those square mechanics, the mechanics within the square, are operational on all squares. This is one. Okay, you can see here, and this is from page 110 of Jensen's book. All right, page 110. He's got the square of 90 here, which he's going to show us in just a minute on a different level. Runs across the top, 0 to 90. Runs across the east here, 0 to 90. Okay. So if you take a look at that right-hand side, you see the red arrow. The red arrow is at the 50% level, meaning it's halfway between 0 and 90, going up the right side of that square. A lot of people don't realize that's a very important concept. What you're looking at here, is actually a scale of 0 degrees to 360 degrees. The bottom, where the 0 is, on the right side, see how it counts down 30, 20, 10, and the 0, of course, is across the bottom, going up the right side. The 0 is where you start. That's the 0 Aries if you want to go that route, or it's just 0. The top, that 90, is actually 360 degrees. You see the arc of the circle running from the bottom right-hand corner to the top left-hand corner. You see the arc of the circle. It's 1/4 of a circle, as you can see graphically here. 4 times 90 is 360. So that red arrow, and this is very important, what I'm getting at here will be, that red arrow is at the 50% level. It's at the 180 degree mark. The 30 and the 60 are at the 120 and the 240 mark. And, you know, the different ones, it goes on up, and that's what he's explaining over here by the top of the graph, the right margin upwards, all that stuff here at the bottom with all those numbers. Those are degrees. But the degrees need to be switched into other degrees. Like you go XA is 86 1/2 degrees. That means that angle from X to A is an 86 1/4 degree angle starting at X. That's what he means. What he's not telling you, and what's a secret within the field, is that A at 86 1/4 is also what degrees of a circle. I want you to figure that out. What is that? What is that A? What degrees of a circle is that A? Very simple to do that calculation. Very quickly with the calculator. Okay. What is that? That's what's important. That's what he's not showing you. He's got 86 1/4 degrees. What he's doing here is he used a protractor, you know, and you do all that angle stuff by hand on a chart. So these guys have to explain it differently than the way we do it today on a current computer system. I hope I'm slowing this down enough for everyone to grasp. I'm really working on that. Okay. You see the line that goes from B over here, which is towards the bottom left, goes up to the middle, which is 0.1. It goes across the over, and it hits at about 62. All right, 62 over there. He calls it line 10, and he says it's 18 3/4 degrees, which is 30 spaces, starting at B. Okay, line 10. What we want to know is what degrees that sucker hits on that right hand side up there. See where it hits 62? You start at B, You almost go through one, you get real close, and you go and you continue on to the right-hand side. What number of degrees is that? Jensen has 18 3/4 degrees. Yes. That's the line he's got there, line 10. What we need to know, what important information is, what degrees is that it hits? Because it hits roughly at 62, and I'm just eyeballing it there. It could be 61 point something. It goes 62 times 4. That's hitting at 248 degrees. Roughly 248 degrees. That's important information for us. So when people, and myself included, originally looked at these charts, they weren't making that calculation. I tell you, you see it? You see the problem? All these people looking at this. All these people looking at this, and they missed it. They missed what he's getting at. 248 degrees is not, or something very close to it, is nowhere on this page or in the literature. You see? So that's an important part. Where that line hits on that square is vital, to say the least, information. Now, another point I want to make that people don't realize is where that sucker hits is the same on all the squares. What do I mean by that? Well, let's just say square of 144, square of 52, square of 90, which is what we're actually looking at here. That line hits at exact same number of degrees. Okay, just the same as 1/3 and 2/3 will always be 120 degrees and 240 degrees. And you can see that because we're just slightly over 240 here, just like our line. All right? So that's information he's left out. That we're a step above Jensen here on what he's showing already. This is IBM. Your homework on this one is to look at this line using the square of 144. Square of 144. Calculate where this line that originates from January 5 of 2022, that's the high up there, at a price of 142.2. Okay, and the line continues on through February 24th, 2022 at 118.81. Okay? Using the square of 144, anchoring the square of 144, January 5, 2022, where does that hit on the square? What number of degrees does that hit on the square of 144? I got to get you thinking about this. Where does that hit on the square of 144? And we need to know the degrees that it hits. That's where I'm getting at. Okay, work on that. I tell you what, this is BA, and I'm signing off. Have a good one. Bye-bye.